Hi, today we're going to take a look at special right triangles. So we're on page 8 in our notebooks, and our essential question is, what are the side length relationships in special right triangles? So remember what special rights are. They are those triangles that have a set of angles that we will come to be very familiar with. So one of them is the 45-45-90 triangle. And then the other one is the 30-60-90 triangle. And it doesn't matter how small or how large they are, as long as they have those angles in the relationship, then we're going to be able to make some good connections with their side lengths. Okay, so notice here we have our note card taped in. So we did this in class. We taped in the yellow one on top, labeled it, and drew our isosceles right triangle here. And then underneath it, we got our bright orange note card. Well, it doesn't look like it's very bright orange on the scan, but in person, it's quite orange. So we taped in the 30-60-90 triangle underneath with just one strip of tape. That way we could flip it up. So after we labeled it like that on the top, then we flipped both cards up and we labeled them the same way underneath, okay? So we have them labeled with their what type of special right triangle they are and the drawing. Let's make sure we have that on the underside of each card. And then we will be set up and ready to start. Okay, so hopefully you guys have your note cards taped in and labeled. These will be great resources as you guys are solving some problems in class and at home. So that's good. Alright, moving on. Alright, so the next thing we're going to do is take a little look underneath our note cards. So I put some notes down here. I'm going to cover those up a little bit. Alright, so flip up your 45-45-90 card first of all, and then in the space that the card covers up, you can create a table. So what I did is I left my card down and traced around it to create the perimeter around the outside of that table. And then we have 3 columns. The first column is labeled leg, and then we have C equals the square root of a squared plus b squared. That's our second column. And then our third column is titled Simplify the Hypotenuse. Alright, and let's connect those ideas to our picture. So looking at our picture, the legs, since they're both congruent, then we can just think of each of them as just leg 1 or leg 2, whatever. They're both just legs. And then we have the hypotenuse is the side across from a right angle. And you guys are all familiar with how we get the measurement of our hypotenuse. And it's just a modification of the Pythagorean theorem. So normally we have a squared plus b squared equals c squared. But if we're solving for the hypotenuse, then we can take the square root of a squared plus b squared. Okay, so let's say that we have a leg that is 5 units long. So up here, let's say this leg is 5. Now if the leg here is 5, then we know that this leg is also 5. So then we take our leg and we plug it in for both values for a and b and solve for c. So in this case, c equals the square root of 50. And that is an exact value of our hypotenuse. But then in our third column, I want to simplify it, okay? So we take whatever we have under the radical and we break it apart into the product of 2 numbers. One of them we always want to be like a perfect square. So we know we can get 50 different ways. We can do 5 times 10, 2 times 25, etc. We're not going to do 5 times 10 because neither of them are perfect squares. So I chose 25 times 2. Because I know the square root of 25, well, that's 5. So I was able to pull that number out of the radical, and that just left me with the 2 remaining underneath. So our simplified hypotenuse in the exact value form is 5 rad 2. Alright, and let's look at the next value in our table. So we're going to do another same thing here, with the leg being measured as 4. Okay, so some of you guys are pretty quick and you're already seeing the pattern. So if our leg is 4, well then both legs are 4, and we can solve for the hypotenuse, and we get the square root of 32. Okay, so we take what's under the radical, and in our third column we're going to simplify that. Okay, 32 is the product of 16 and 2, which is awesome because 16 is a perfect square. So we do the square root of 16 is 4, pull out our 4, and we just have 4 rad 2 for our simplified answer. Guess what comes next in the table? You got it. 3 is our next leg. Okay, so we fill out our table there, and we can continue on with 2 for our next leg. Kitty, be quiet. Come here, Kitty. Sorry, that's my cat. She needs attention. Okay, going on, we can do the same thing if a leg was measured 1 unit. And then last of all, since we've seen the pattern, now we can just, throw in a variable. Let's just use L for leg. And so we plug it in the same way, and we simplify it down, and we find out that the hypotenuse is the same thing as L rad 2, or any leg times rad 2. Okay, so there's our completed table for our 45, 45, 90 triangle. Sorry, my cat's being super annoying. Okay, the next section that we need to look at is our 30, 60, 90 triangle. Let's skip down a little bit here. Flip that card up, please, if you will, and we'll create another table underneath that one. Now, since these 3 sides are of different lengths, I just called S the shortest side. So that would be the side across from our 30-degree angle. That one's going to be called S, okay? And then the other leg is a much longer leg, so I call that one the long side. And then, well, hypotenuse is hypotenuse, so there it is. Okay, so let's say that our shortest side was 10 units long. And so I set that in the table, and I figured out what the long side would equal, and I figured out what the hypotenuse would equal. And you can see it's a little bit of a cluster of work there because we have to go through all the steps of using the trig. And let's just look at that example, kind of draw it out. So here is the same triangle, and let's say that we have a 10 right here for our short side. And we don't know what our long side is, so we have X there. Alright? And we're going to relate them, both of those sides, to 60 degrees. Okay? So to solve for X, we're looking at the opposite side and the adjacent side. So opposite over adjacent, well, that's tangent. So here we have tangent of 60 degrees is equal to the opposite, which is X, over the adjacent, which is 10. Okay, and then to solve for X, here we can multiply both sides of our equation by 10. So times 10 here, and times 10 there. These will cancel out, leaving us with X equals 10 times tangent of 60 degrees. Okay, so X equals 10 times the tangent of 60 degrees. Now, there's something cool here, and I want to take a look at it on the calculator. So let me grab my Wabbit Emu calculator, and if you have your calculator with you too, you can type this in. Make sure your mode is on degrees, and then let's take a look at what tangent of 60 equals. So just type in tangent of 60 degrees and enter. Okay, so we get a really long, probably irrational number here. It doesn't seem to have a pattern. But then, if we do this, second square root of 3, something cool happens. See that? Same thing. So the tangent of 60 degrees is really the square root of 3, or rad 3. You can say it either way. So here, back to our work, we had x equals 10 times tangent of 60. Well, we can rewrite that and say, well, x equals 10 times rad 3. Just replace tangent of 60 with rad 3 because they're equivalent. And this is an exact solution for how long the long side is if the short side is 10 units. Okay, let's minimize all that and go back to our table. So now we know tangent of 60 is equal to rad 3. And I put that question in our notes over here. What does tangent of 60 degrees always equal? So that's a good thing to add to our notes too, okay? So we have the approximate decimal and it equals rad 3. Alright, and we had a little note over here on how we were able to solve for the long side. Alright, and then the hypotenuse is across from our right angle. And so if our short side was 10, we would do the sine of 30 degrees is equal to opposite over hypotenuse. So, you can do that math, or you can look at how that would look here. So, in this case, 10 will be our opposite side. It's opposite of 30 degrees. And then we're solving for our hypotenuse, okay? So that's what we're looking at. In order to solve this one, we'd have to do cross products to solve and isolate our variable h, and we end up doing the hypotenuse is equal to 10 divided by the sine of 30 degrees. Okay, so we put that in the calculator. Let's grab that, move over it over. Okay, so now we have 10 divided by, oops, that's not 10, go back, try that again. 10 divided by the sine of 30 degrees. And that equals 20. Now that's a pretty nice round number, and so that gets me to thinking, well, we figured out what tangent of 60 degrees equals all the time, rad 3. So what about sine of 30? Is it something special? We're dealing with special triangles, so I bet it's pretty special. Let's check it out. Sine of 30 degrees is always equal to 1/2. There it is, 0.5. So that's important. Let's add that to our notes, okay? So, take a look at our notes. And the table kind of continues. You know, there's the table. You can fill out your table as well. So what does sine of 30 degrees always equal? Well, now we know. Sine of 30 degrees equals 1/2. And let's look at the relationships that we can see in our table now. Whenever we have a short side on our triangle, on our 30, 60, 90 triangle, we can take that value and we can just call it S, S for short side. And we can multiply it by rad 3 in order to get the long side, the leg that's the longer leg. We can also start over again and have our short side, and we can just double it, multiply it by 2 to find out how long our hypotenuse is. So all three of those sides have this beautiful relationship. Yeah, they're quite happy together. So now, let's add those relationships onto our cards. And we're going to use the same abbreviations that we used in our table. So on the top flap of our 45, 45, 90 triangle, let's go back to that card. Please label your legs L, and then your hypotenuse can be labeled L times rad 2. Okay, so going back to our table here for this one, remember every time that we simplified our hypotenuse, it ended up being the leg multiplied by rad 2. So yeah, that's where that came from. Alright, so back to labeling our cards. Getting those all set up is a great resource. So once you have this card done, then you could look at any old special triangle, and if you know your leg is, let's say, 15 inches, then your hypotenuse is 15 times rad 2. Done deal. So that's our exact answer, and if you want to get an approximate, we'll just type it into the calculator. Okay, so let's say that we have that. Let's move this guy over again. Okay, clear that out. So yeah, if we had a leg that was 15 units long, then our hypotenuse would just be 15 times rad 2. And these calculators are awfully smart. I don't even have to do like a multiplication sign or anything. Okay, and then there's our approximate, and we can like round this off to the nearest thousandth or whatever if we wanted to. But we can see that the hypotenuse is, you know, it's about 21 units long. But it's nice to see that exact form because sometimes that's all we need for our answers. You know, just leave it with the radical. Keeps it nice and simple. Okay, so we have that note card done. Now let's go ahead and label our 30, 60, 90 note card as well. So here's that one. So I put an S next to the short side. Please put an S next to your short side. And our other leg that's longer, our longer leg, was the short side times rad 3. So here's S rad 3. And our hypotenuse, remember it was always twice as long as our short side. So we have 2S for our hypotenuse. Okay, so we got those labeled. And now, last thing. One more thing to add to our notes. We're going to add a little bit of things to the undersides of our note cards. Alright, so what do you notice about this triangle right away? I labeled the hypotenuse H, right? And now we knew before that the hypotenuse was the same thing as the leg times rad 2. So then going the other way, if we want to know what the leg is, we can take the hypotenuse and divide it by rad 2. Okay? So the leg is equal to the hypotenuse divided by rad 2. So it's just working backwards. And then I rewrote that down below, and I wanted to rationalize the denominator. Remember that rationalizing the denominator just means making sure that we don't have any radicals downstairs, okay? We can have them up in the numerator, that's fine, but we want to get them out of the denominator. So in order to do that, we can just multiply it by its twin here, and whatever we do to the denominator, do the same thing to the numerator. That way it's kind of like taking a fraction and multiplying it by 1. We're not changing its value, we're just renaming it to make it pretty. Okay, so if we times the denominator by rad 2 times rad 2 gives us 2. And then for our numerator, the hypotenuse times rad 2, just write it as h rad 2. So then that is the value of our leg. And remember, both legs in a 45, 45, 90 triangle are congruent. So they're both labeled the same. And then from there, once you have this formula, again, you can plug in any number for h and solve for your legs. So up in the little cloud up here, I said, well, what if the hypotenuse is 1? What would my legs be equal to? Well, 1 times rad 2 divided by 2 just leaves me with rad 2 over 2. And this little cloud here is going to come in handy when we work on a unit circle later on. So keep that in mind. Alright, let's move on. And you guys can pause here if you need to keep looking at that or thinking about it or taking notes, okay? But I'm going to look at the 30, 60, 90 triangle. Alright, so we found out on the front side of our card that if we had the short side, then the hypotenuse was always twice as long. Now if we know the hypotenuse, then that just means that the short side is equal to the hypotenuse divided by 2, right? So there's that. We're putting it in terms of the hypotenuse. Now I have the short side is h divided by 2, while the long side is always going to be the short side times rad 3. So just stick rad 3 up in the numerator, and then we're good to go. Alright, those are the side length relationships there in our special right triangles. And here's another little cloud off to the side where I plugged in 1 for the hypotenuse. Again, you can plug in any value here for h and solve for your legs, and just make sure you simplify everything. So here we have the longer leg is rad 3 over 2, and then the shorter leg is equal to 1/2. And again, we'll be using some of those values in a unit circle later on, but not today. Alright, so I think that is it for notes for today. If you have any questions, please let me know. I'm always glad to help out. Alright, thank you guys. Bye.